Hello everyone, welcome to Elevare. This is Fahim, and today we'll be solving a question from measuring rates. This is one of the question that is most commonly asked in your exams, and I did find a lot of students struggling with this question. So, without wasting any more time, let's just crack this question down into the simplest chunks, okay? So that whenever you do encounter one of these questions, basically there isn't any scope that you'll be losing any sort of marks. Let's just move into it. So it says that a solution of hydrogen peroxide decomposes when a catalyst of manganese 4 oxide is added. Okay. The products of the reaction are water and oxygen. So these are the products of the reaction, then these are water and oxygen. Now it said that complete the chemical equation for the reaction. Now we basically need to balance this reaction. Okay, so how do you even balance this? So first of all, let's check something. There are two hydrogen and there are two oxygen. There are two hydrogen over here and there are three oxygen over here. Now, how do you even balance this? Okay, so let's just do some trial and error. Okay, so let's just give two over here. If I give two over here, then there are a total of four hydrogen. There are a total of four hydrogen, and now why four hydrogen? Two times two, right? So four hydrogen 2 times 1. There is 1 over here, right? So 2 times 1, 2 plus 2. And there are 4 oxygen. 4 oxygen. There are 4 hydrogen and 4 oxygen. Okay. Now, what can I give over here to make sure that the number of hydrogen and oxygen over here on the reactant side matches equally with the number of oxygen and hydrogen in the product side. So we know that there are four hydrogen and four oxygen, right? Now what I could do is I could give a 2 over here. Now if I give a 2 over here, what I could see is that 2 times 2 4, 2 times 2 4. It means that there are 4 hydrogen and 4 oxygen in the reactant, and there are 4 hydrogen and 4 oxygen in the product. This means that both the reactant side and the product side are balanced. Okay. Oh, okay. So since there's a blank, you basically need to give one over here since you aren't altering anything, right? So yeah, this basically completes this equation, right? So whenever there's this hydrogen peroxide in the presence of this catalyst, it is going to decompose, it is going to break down to form water and oxygen, and this basically is the main gist of the question. Okay, now it says that give a test for oxygen, so you basically have to insert a glowing splint, right? So it relights a glowing splint. This is one of the most common question that you have to encounter in your exam, right? So it relights a glowing splint, relights. It relights uh it relights a glowing splint. It relights a glowing splint. SPLINT. Okay, one of the most common tests. It relights a glowing splint, right? So yeah, moving on. State the reason for adding a catalyst. It basically increases the rate of reaction. Increases the rate of reaction. Increases catalyst increases the rate of reaction, increases the rate of reaction, the rate of of the reaction. Catalyst basically increases the rate of the reaction. A student investigates how changing the concentration of hydrogen peroxide, changing the concentration of hydrogen peroxide solution affects the rate of this reaction. Okay, so they are basically trying to figure out what basically happens when you change the concentration of hydrogen peroxide. Now, first thing is that how could you even measure rate? So what is the formula of rate? What basically is the formula of rate? Rate is equivalent to the change in something, right? Change in something. Change in something. Let's just say that something to be x. Change in something divided by time. Rate is what? Rate is change in something divided by x. I hope you all are acquainted with this formula, right? This formula is not unknown, okay? So yeah, this is the formula of it. Now in this apparatus, there's this catalyst, there's this hydrogen peroxide, right? And whenever you open up this tap, the solution falls over here, right? And as a result, the reaction takes place. And in the reaction, two products are produced, okay? One is water and the other is oxygen. Now, oxygen is a gas, right? So oxygen would be produced in this reaction, so oxygen, right? Now, what? Why would the oxygen go? Since it is a gas, it goes from over here and gets collected in the syringe. Oxygen from here goes and gets collected into the syringe. Now you could figure out the volume of oxygen produced, right? You could figure out the volume of oxygen produced from this syringe. As the oxygen would be producing over as the oxygen would be produced over here, it would start to move through this tube, right? And as a result, it would exert some sort of a pressure, right? And push this plunger and push this plunger, right? And push this plunger to the right. Now let's just see how this mechanism works, right? Since many of the students are not clear with this. Okay, sorry for the drawing, guys. Just make sure that you do not face any problem while solving this type of questions again, right? So this is suppose the plunger, okay? And these are the oxygen gas particles. And this is basically exerting some sort of a pressure, or you could say force, right? Force on this plunger head, right? And as a result, the plunger that was initially over here would now shift over here, would now shift over here. New position of the plunger, right? Now, basically, there was a reading over here, initial reading, right? Initial reading. Initial reading over here, right? And once the plunger is pushed over here, there is going to be a final reading. Final reading. Final reading. So what basically is the volume of oxygen that was produced? This is the final reading. So what basically is the volume of oxygen that was produced? So the volume of oxygen is going to be volume volume of oxygen is going to be equivalent to final minus initial reading. Final minus initial reading. Now, this is going to be the volume of oxygen. And if you figure out the time taken to produce this volume of oxygen, you could easily figure out the rate of this reaction. Now, are you clear? What I said is that if you could figure out the volume of oxygen produced in this time period using a stopwatch, you could easily figure out the rate using this equation, change in x, change in volume divided by time, and hence you'll be figuring out the rate as easy it is, okay? So yeah, this was the overall procedure so far. Now let's just check out the question that they do need us to complete. Okay, so the student records the volume of oxygen. The student records the volume of oxygen that collects every 2 minutes for 16 minutes, okay? 2 minutes for 16 minutes, and the table shows a result. 16 minutes, and this is the volume of oxygen produced. Now plot the results on the graph. Draw a circle around an anomalous result. I mean, this is the result that does not fit the overall trend, okay? So anomalous result is the one that does not fit in the overall trend. not falling into the overall trend. Not falls in the trend. Not falls in the trend. Okay, it does not fall or it does not lie in the overall trend. And draw a curve of base fit. We basically need to draw a curve of base fit through the points and ignoring the anomalous result. Okay, understood. So let's just plot up these values. Okay, so they have basically completed the y-axis and x-axis for us. Now let's just figure out something. Okay, 0, 4, 8, 12, 16. Let me just check something. 2, 4, 6, 8. 2, 4, 6, 8. Okay, so this is 0. This is 0. This is what? This is what? This is 4 and this is 8. Okay, this is 12 and this is 16. Now, what does this represent? What does this represent? So let's just figure that out. Give me a moment. Let me just get my calculator a bit quick. Sorry for the delayed one. Just give me a moment. Let me just calculate this. 4 divided by 10. Okay. 4 divided by 10. 0.4 times 5. Okay. So what you're going to do is, let's just show you how to figure out what each of these unit represents, right? So let's just check something. 10 of these small boxes represents 4. What? There is how many small boxes over here? There are 10 small boxes over here, right? So 10 small boxes is representing 4. So let's just use some unitary method knowledge, okay? So 10 small boxes, 10 small boxes represents 10 small boxes represents what? A value of 4. So what does one small box? So what does one of these box represent? So one small box represents 4 divided by 10. 4 divided by 10. This is what? This is equivalent to 0.4, right? This is equivalent to 0.4. If one of these small box represents 0.4, 0.8, and so on, then what does this box represent? So if one of this box represents 0.4, then how many boxes are over here? 5 boxes, right? So 5 box represents what? So let's just use this. Like suppose if one of the small boxes represents 0.4, then therefore 5 small boxes would represent what? 5 small boxes would represent what? 5 small boxes would represent 0.4 times 5. This is what? This is coming as 2, right? So it means that this is 2. This is 2. This is 2. If this is 2, then this is what? This is 6. You could say how this is 6, okay? This is how is this 6, right? So I know that one of the small box is equivalent to 0.4. Then how many small boxes are over here? 5, 5, 5, 15, right? So 15 times 0.4. 15 times 0.4, that is 6. 15 times 0.4, that is 6. Now I do figure out most of the students facing issues with these scales. I hope this trick would help you to discover it, okay? To discover or to figure out the units of it. This is 10. This is 14. I hope this trick, whenever you are having some issues with figuring out this sort of scales, just use this unitary method maths. Just use this unitary method math. Okay? Just use your math student knowledge in you. Hence, life would become easier. Now, I have the points. Now let's just check for the x-axis, right? So what does one of these units represent? I know, we know that 5 and 5, right? So 10 small boxes represents 20. This was for x-axis. This was for x-axis. Now let's just figure this out for y-axis now. This was for x-axis, right? Now let's just figure out the scale for y-axis as well. Y-axis. Now let's just figure out this y-axis. I know that 5, 5, right? So 10 small boxes represents 20. So 10 small boxes, 10 small boxes represents, so 10 small boxes represents what? 10 small boxes represents a value of 20. A value of 20. So one small box does what? One small box represents what? 20 divided by 10, right? So 20 divided by 10. So this is going to be 2. Okay. So 20 divided by 10. So cut this 0 out. So this is going to be 2. So one of the small box is representing 2, right? So this is going to be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and so on. Okay. Now I have both the scales for y-axis and the scales for x-axis as well. I hope you all are clear with this. If you do have any issue with this, then do let me know in the comment section below. I'll be making a separate video on figuring out the skills as well. Okay. Now let's just plot this. For 0, this is going to be 0. For 0, this is going to be 0. While plotting up these graphs, do not use this dot, right? Use this cross, use these boxes, use this cross. Do not use up this dot, okay? For 2, this is going to be 22. Now this is 20, this is 20, and this is 2. One small box, remember, represents 2, okay? So this is going to be 22. For 2, this is going to be over here. So for 2, this is going to be over here, 22. Now for 4, this is going to be 38. 38 4, right? So this is 30, no, 38, 20, right? 20, 30, 32, 4, 6, 8, 38. For 4, this is going to be 38. For 4, this is going to be 38. 38. Okay. Now, just a moment. For 4, this is going to be 38. For 6, this is going to be 50. For 6, this is going to be 50. This is 40, 42, 4, 6, 8, 48, 50. So for 6, this is going to be 50. 6, this is going to be 850. And then for 8, this is 55. For 8, this is 55. For 8, this is 55. For 8, for 8, this is 55. Okay, I know that this thing is 50. This thing over here is 50. Right? So 55 is what? So I know that this is 50, right? This is 52, 54, 56, right? So this is 54 and this is what? 56. So 55 would be where? 55 would be lying in middle of these two, right? Again, 50, 52, 54, 56. This is 56. This is 54. Now, where would 55 lie? 55 would lie exactly between these two values, 56 and 54, right? So this is what this is. This is 50, 52, 4, 6, right? So this value over here is going to be 55. This over here is going to be 55. 55. So let's just recheck. 50, 52, 4, 6, 8, right? So this is going to be 55. So for 8, that is going to be 55. So for 8, that is going to be 52, 4, 55. So exactly in the middle. Exactly in the middle. You have to be careful while plotting out this, okay? Now, for 10, this is going to be 69. So again, same thing would happen, right? So for 10, 69, right? So 69, 68, and 70, right? The middle of it is going to be 69, similar to this one as well, right? So what was that for 10? That is 69. 69 is what? This is 68, 62, 4, 6, 8, and this is 70, right? So 69 would be lying between this. 69, 69. This is gonna be 69. Exactly in the middle, okay? 69. Done. So for 10, that is gonna be 69. For 10, 69. 10 we have over here. 10, 10 is where? 10 we have over here, and 69. Okay, this is gonna be 69. Now 1276, 80, 80, right? So 1276, 76. This is 70, 72, 4, 6. For 12, this is going to be 76, 78, 80, right? So yeah. So for 12, this is going to be 76. This is 12. So this is going to be 76. 76. And then 14, 16, 80, 80. 14, 16, 14 and 16 is going to be 80, 80. This is 80. This is 80. Now, I could have done this graph before even making this video, right? But I wanted you all to figure out how would this even look like. I wanted you all to do this graph, to struggle with me, to figure out everything, okay? Now we basically need to draw a smooth curve. So the curve would look something like this. This is the curve of base fit, right? And this result does not fit our overall trend. So this one is going to be our anomalous result. As this does not fit our overall trend, this is what we refer to as being our anomalous result, right? Now let's just draw this curve. This is gonna be a bit tough for me. Okay. This is gonna be a bit tough for me to draw. Okay, right? So something like this. Something like this. Since I'm drawing using this digital apparatus, okay, so it should touch these points, right? And if it doesn't even touch these points fully, it is okay, right? Because these points are close to this line, okay? So you basically need to draw a line of base fit. You have to ensure that it touches approximately most of the lines, right? And this is the line of base fit, right? And this is basically gonna be our anomalous result. So circle on this. Anomalous result, okay. Moving on. So suggest This is basically a suggestion question. So let's just see what is that. Um, Suggest a mistake that the student might have made that resulted in this anomalous result. Okay, that caused this anomalous result. Now let's just check something. Now, if I was to comment on this, the points should have lied over here. The point should have been over here. See, the point should have been over here. The point should have been over here. Right? The point should have been over here. But see the point, right? If this was to lie in that overall trend, the point should have been over here, but the point is over here. Now, what basically is the reason behind this? Volume of oxygen and time in minutes. Now, the volume of oxygen should be higher, right? The volume of oxygen should be over here, but the volume of oxygen in the experiment is this, right? So the volume of oxygen is low, but over here the volume of oxygen was high if this was to fit into that overall criteria, into that overall trend. So what could be a reason behind this? One reason could be that the person, just let's just check something. For 8, what I'm saying is that as time is increasing, the volume of oxygen produced is increasing as well. Since the volume of oxygen should have been higher, it means that there's an issue with this reading. The person did take this reading before 8 minutes. As a result, the volume of oxygen was lower. The volume of oxygen should have been higher. See? But the person basically, instead of taking the reading at exactly 8 minutes, took the reading at like 7 minutes or 7.5 minutes and so on. Or you could even say that the person misread the volume of oxygen. Okay, so this should be the answer of it. The person misread the volume of oxygen, or the person took the reading of the oxygen volume. Let's just go with the first one. The person, the student, took the reading took the reading of the volume of oxygen of the volume of oxygen and the volume of oxygen before 8 minutes. Oxygen before 8 minutes. Before Okay, so yeah, moving on. Determine the volume of oxygen collected during the first 3 minutes. Okay, the volume of oxygen collected during the first 3 minutes. So 3 is over 3. How many boxes would mean 3, right? So let's just do something. I know that, I know that, I know that each of these boxes represents 0.4, right? So how many small boxes represents 3? So let's just try to figure that out, right? So let's just again use that unitary method thing. So 5 small boxes represents 2. So 5 small boxes represents 2. One small box represents what? 2 by 5. Okay. We're gonna have to shift this a bit. Okay. So 2 is being represented by what? 5 small box. 1 is then being represented by 5 by 2 small box. Therefore, a value of 3 should be represented by what? How many small? 5 by 2 times 3 small box. So this should be 5 by 2 times 3. This should be 7.5 small boxes. 7.5 small boxes. So 7.5 small boxes should mean 3, right? So 5, 6, 7, 7.5, right? This is 5 small boxes, 6, 7, 8, 7.5. 7.5, 6, this is 5, 6, 7, 7.5, right? So this should represent a value of what? 3. Now, see, if you are that advanced math student, now you could do this, right? But for someone who's a beginner, right? If someone who's a beginner and is confused with how to answer this type of questions, I have basically showed you a way to figure out these skills in the most simplistic way that you can at this point, okay? So yeah, this is 3. Now let's just see what is the volume of oxygen when the time is 3. Mm, this is what? This is 20, 22, 4, 6, 8. This is going to be 30. 30, right? So yeah, the volume of oxygen is going to be 30 cm cube. 30 cm cube. Mhm. And now the last part of the question, it says that the student repeats the experiment using the same hydrogen peroxide solution, okay, of half the concentration. Now this is the most important part, of half the concentration. Now, what do we know? What do we know about it, right? So first of all, as concentration increases, rate of reaction increases as well, right? Now, since you are decreasing the concentration, since you are decreasing the concentration, the rate is obviously going to decrease as well. Since you are decreasing the concentration, the rate is gonna what? The rate is gonna decrease as well. First of all, as you decrease the concentration of hydrogen peroxide, the rate is gonna decrease as well. Secondly, the volume with this concentration was 80. Since you reduced the concentration of hydrogen peroxide, the volume is going to reduce to 40. Why? Because you're reducing the concentration of hydrogen peroxide by half, right? So the volume of this should be divided by 2 as well. So the volume with half the concentration of the volume of oxygen with half the concentration of hydrogen peroxide should be 40, right? So with the initial concentration, while you first carry out this experiment, the volume was 80. Now you basically decrease the concentration, you basically decrease that concentration of hydrogen peroxide, which means that the volume should become half of that initial volume as well. Now you have to remember this. If you are still unsure about this kind of questions, I do have a separate video on this type of questions as well. Do let me know in the comment section, everyone, okay? And this part of this, right? The initial part of it, right? The initial part, the gradient of it represents rate of reaction. Rate of reaction, right? So if you find the gradient when during this initial part, right, when time equals to 0, you would find out the rate of reaction. The gradient. So for a reaction where the concentration was half, the gradient would be less steeper. Why would be less steeper? Because the rate of reaction decreases, right? So a graph whose gradient is steeper increase shows that the rate of reaction is high. But for a graph whose rate of reaction is lower or whose rate of reaction is slower, the graph would be less steeper than this, right? So the graph should look something like this. Clear? So yeah, the graph for this should look something similar to this. It should be leveling off at 40, right? Okay. Yeah. It was leveling, it should level off at this volume. It should level up at this volume. Right now the graph should be smooth, but since I'm drawing it digitally, it isn't that smooth as well. Okay. So yeah. Now, moving on, just a moment, everyone. Moving on. So the last question, explain how using hydrogen peroxide solution of half concentration affects the rate of reaction, right? Explain the collision theory in your answer. Sure. So as the concentration decreases, rate of reaction decreases as well, right? So as the concentration, as the concentration of H2O2 of H2O2 aqueous decreases, rate of reaction decreases as well. Rate of reaction rate of reaction decreases as well, right? This is a common question that you'll be encountering in your exam. The rate of reaction decreases as well. Why? Because there are fewer molecules in the same volume, but there are fewer particles in the same volume, and hence there are fewer collisions, right? Or frequency of collision decreases. This is because as you decrease the concentration, there are fewer particles in the same. This is because there are fewer particles. This is because there are fewer particles in the same volume. Since the volume is the same, but the concentration decreases, right? So there are fewer particles in the same volume, and hence there are fewer collisions per unit time, right? Or frequency of collision decreases. Hence, there are fewer collisions per unit time. There are fewer hence there are fewer collisions. So you'll call this collisions. Hence there are fewer collisions per unit time. Or frequency of collision. So yeah, everyone, that brings us to the end of this question. I hope you found this video to be helpful. If this was helpful, then make sure to like, comment, and subscribe and share with anyone who is in need of this. Have a great day, everyone. All the best for your upcoming exams.